Alright, so like I said, you guys can put this in your foldable or you can put it, that's the only packet that doesn't have a blank page after the cover. All the other ones will have a blank page, so it'll be with the review packet. Alright, so starting off with separable differential functions or equations. I just want to start off with what they are. So if you remember, those were the derivatives that are given. They're always given with a function of x multiplied by a function of y or divided. And it doesn't actually matter which function's on top, whether it be the function of x or a function of y. So that's how you know that's going to be a separable function, or sorry, equation. Then from there, just to show you what they look like, something like that, or something like that. Those are considered separable. You can separate the x's from the y. So that's what the separable is referring to, the fact that all your x's and all your y's can be completely separated. Alright, so then looking at the steps that you have to take. So if you want to separate, first thing you want to do, you want to separate your terms by multiplying or dividing. That's the first step. Notice what's there, multiplying and dividing. You are not permitted to add or subtract to the other side. Okay, it has to be multiplying or dividing. You're going to integrate both sides. Okay. You're going to add your plus c and simplify. Remember, you only do that to one side. A lot of you guys keep asking me that. You only add plus c to one side. And then you're going to attempt to solve for y. Most of the functions, they want y by itself. Sometimes you get away with not having to do that. Alright, so I'm going to do an example problem from your packet. So I think it's number 11. So turn your packets to number 11 so you can see the question that we're going to do. If you know how to start the question, go for it. That's why I'm leaving that up, Josh. Okay. So number 11 should be a separable function or separable equation. Go ahead and get started on that while I wait for everyone to copy our steps. That's pretty much it. And then that's just a method of integration. All right, go ahead and try number 11. Mm-hmm. All right, I'm going to give you guys a little bit of time to try to. All right, so separate. That's your first thing. I'm going to move my y's to the left, my x's to the right. You're going to integrate both sides. That was your step 2. When I integrate both sides, Lottie, what does the left side give me? ln of y, ln of, yep, you need the absolute value, equals, JP, what does the right side give me? One-third, x to the third, and then what do I need? Plus c on that side. All right. I always add my plus c's on the x side. All right, Nathan, what do you think I should do next? How? E to the everything. That works for me. E to that whole thing. So my ln and e will cancel. Good. I'm going to come over to the right side. And we get absolute value of y is equal to e to the 1/3 x cubed. And instead of the plus c, Noah, what can I write instead of this plus c right here? Good. Times e to the c. Thank you. All right. Now, if I want to just get rid of the absolute value, Ramsey, what should I do? Add plus or minus. I'm going to reorder my information here. I'm going to put that in front first, and then e to the 1/3 x cubed. All right. And then, now that I have this whole thing all together, Annie, what should I call that instead? A. All right. So, now that I have that, what's your actual answer? C. Yeah. All right. Awesome. Okay. Next, I'm going to go over initial value. All right, so initial value problem, I describe what it is, and then we'll do an example. So an initial value problem, you use integration. I'll read it to you. So initial value, that should be in the same tab. Am I correct? No, it's a whole new tab. So field tab? Okay, that's fine. All right, so field tab. So use integration to find an equation. Use integration to find an equation. Then use a point xy to solve for c. So an initial value problem, it just adds one little step to a process. It adds one step to integration. You want c to be a number, a physical value. So we'll end up doing two different initial value problems. All right. The first one we're going to do is number 5 in your packet. If you go to number 5, if you want to write the question inside of your foldable so you have an example, you're welcome to do that. So, number 5, they give you the velocity, and at time equal to 0, the position is 4. That at any time its position is. So there are your answer choices. Go ahead and get started. Let's see what you can do, and then I'll go over the question with you in a minute. So again, we're going to go through this question, but I'm going to extend it to a harder question, and I'm actually going to show you the other answer that could have shown up, but your answer choices is how you know which type of answer to give. All right, so you start off with velocity. This one I'm just going to run through so we don't run out of time. All right, so you start out with velocity. I'm not going to do a separable. I'm not going to show that kind of step, but I know that if I want to find the position, I would need to integrate. So because I need to integrate this, you end up with t squared minus 4t and then the plus c. If you want to turn it into a separable function, the way that this problem would work, you would do a dv over dt equals 2t minus 4. And then multiply dt to the other side. Same as what we did before. All right, so now that I have my plus c, I know that the point originally on position, the x function, is 0, 4. Substitute that in. We get 0. I'm going to show my work just so you have it. And then plus c. Therefore, c is equal to 4. Therefore, my position function is t squared minus 4t plus 4, which gives us letter C. Notice letter B, the only difference was that minus 4, so if you made a little mistake, you could end up with a minus 4. All right, so that's one answer. You actually learned how to do this differently before. Sub a plus the integral from a to t of velocity. Remember, we always said if you integrate, you need an initial value to start. This is the other answer that could have been given, but you would know that they want that answer because there'd be integrals everywhere. So this one would be x sub t is equal to the initial value, 4, plus the integral from 0 to t of t squared minus 4. Oh no, we'll see. 2t minus 4, right? Yeah. They'd probably put like another variable in there instead, but that's the other answer you could have had. Before we learned how to physically integrate, we did this first. All right, one other extension. Let's pretend that it's not velocity, but that acceleration was 2t minus 4, and the question doesn't change. I want position. Okay? So we already found this, right? So that actually doesn't change. If you're asked to find position, you still need to find the full velocity function. Problem is that when you find position, you would be doing the integral of this guy, which is the velocity. Makes sense so far, right? I'll just put a dt there. All right, so we get x of t is equal to t cubed over 3 minus 4t squared over 2 plus 4t. And what should I put in the back? Not plus c. You want to pick a new one. What you can't do, don't you dare try to put C and D here. Doesn't work that way. You got to find your plus C's right after you integrate. So you found it the first time, got your plus 4. You use the 4, that's how we get the 4t. Then you use a new constant D. Okay? That's the extension, that's the harder one. All right, last thing, slope fields. So, my kind of definition of a slope field. So my definition of what you do for slope fields would be that you're given the derivative, use points x, y, given the derivative, use points x, y to find dy dx, at each point. And then remember, you just had to draw a bunch of tangent lines. So if you have a positive tangent line, just make sure it goes up. Ramsey, you okay? I know. I see you trying. Your negative ones, you go down. Your horizontals are your zeros, where your slopes are 0. So that's supposed to look like a horizontal line there. And then don't forget your undefined points. You're just going to leave those blank. You don't put anything in those. Okay, so those are essentially the 4 different types of derivatives you could end up with. So we're going to complete question number 25, but we're not going to do the part A. I'm just going to show you the best way to approach part A, but we're not going to do it. Okay? All right, so 25, your part A, I noticed when we were doing our slope fields that some of you took a really long time, but then still got it wrong because you didn't want to write anything down. I would suggest that if it takes you a long time, then write something down. Don't try to do it all in your head. So what would I write down? Well, for this question, I would make a table. I don't do these well in my head because I lose my place. So I would make a table. My y values are 3, 2, 1, 0. My x values are -1, 0, 1. And then I, physically make a table. And I fill them out. So I would have all, in this case, 9 of my slopes, or 12 of my slopes, 12 slopes written in, and then I draw them in. It does seem to make it easier than to try to memorize each part, and then you make a mistake. This way, if there's zeros, you can fill in the zeros right away also. Okay? That's the table that I talked to you guys about if you're not doing the mental math correctly. All right? We're going to focus our energy on part B and C. Those are the 2 major things that they tend to ask for these questions. So part B says, given that you have 12 points, they don't want you to think about just the 12 points. They want you to think about all of the points possible. And it says, describe all the points for which the slopes are positive. So here's my slopes. And I want the slopes to be positive. Someone describe to me what happens with this x squared, though. No matter what I put in there, you usually get positive numbers. All right. Second part here, this is what's going to give you your actual sign. So we don't care about the x squared when it comes to positives or negatives, because it's always positive. We care about this guy. This is an easier one. You know that y equal to 1 gives you a 0, and most of you can figure out when is this going to be positive, when y is greater than 1. So that would get you no points, because that's not the answer. What am I missing? Someone raise your hand if you know what I'm missing. We are missing something. Someone raise your hand if you know the answer. Timon? Yeah. We always talk about x squared always being positive, but in reality, it's always positive and 0. You got to remember that it can be 0. So in this case, you always have to have the extra statement of make sure that the x squared isn't 0 if you want the slope to be positive. So you need both parts to get your full credit. You would lose the point of the answer in this case. I believe this probably only comes with 1 point. You would lose your whole point by not putting that in, even though you probably know and it's easy. Okay? All right, and then part C asks you to find the particular solution where y is equal to f of x to the given differential equation with the initial condition f of 0 equals 3. This is very specific. Because it says y equals f of x, it tells you that when you're done your answer, you better have a y equals equation. You can't have a y plus something equation. It has to be y by itself. That's what this says. If it just said find n equation, then you could do any kind of equation. Y doesn't have to be by itself. So be very careful when it says this. Y has to be by itself. All right, so let's do that question. So dy dx equals x squared times y minus 1. Separate. So separable differential equations, it's just a way to integrate. It's another method of integration. So I'm going to move this guy over to the left side. Okay, and then I'm going to integrate. Raise your hand if you know on the left side what rule it's using. What do I need to do on the left side to integrate? No idea what the cricket is. Noah, what do you think? Because I'll show you what it's not. I'll show you what it's not. That is definitely not what it is. Okay? Joshua, what do you think? It is a natural log. So let's talk about how you know.
Because it's over a y, it's a y to the 1.
So essentially, that right there is always going to give you an ln. And there's others. There's many more examples of what will give you an ln when you integrate. This, when the bottom term is linear, that's usually an ln. Okay, when the bottom term is linear. If it's to any other power other than 1, it's not ln. Okay? If it's 2, then it's a power rule. Chain rule reverse. Yes. Review syllabus. That. Okay? So, how do you want to do that? You want to reverse the chain rule, or you want to do a substitution? Substitution? So, if you don't really understand how to reverse a chain rule, don't do it. Do a substitution every single time. Okay? Reversing a chain rule is just a quick way to do a substitution. Don't use it if you know you make mistakes. Just get rid of that and do substitution every single time. All right, so if I'm going to do substitution, I need my substitution. What should my u be? Y minus 1. All right, so du over dy is equal to 1. Therefore, du is equal to dy. That makes the substitution very nice and easy. So when I come over here, my dy becomes du. My y minus 1 becomes u. And on the other side, I still have my x squared dx. Any questions on doing that substitution? Okay. Now I integrate du over u. That gives me ln of the absolute value of u. This side we just did a second ago in the last question. And don't forget your plus c. It's actually very similar to the question you did before. I think Nathan already told us how to get rid of this big guy, so I get rid of it by using my e, cancel, come on over, and we end up with the absolute value of u. I'm going to replace my u now, because I want it in terms of y. E to the c. Alright, let's get rid of the absolute value, along with this e to the c all at once. I'm just going to skip one little step there, because we did it literally in the last question. Alright, and then we get this. Y is equal to a e to the 1/3 x cubed plus 1. What was the initial point? 0, comma, I believe 3. Was it f of 0 equals 3? Alright, so substitute that in. We get 3 is equal to a e to the 0 plus 1. Therefore, a is equal to 2. And if I stop right there because I got my a value, you would lose a point at the end. Okay? So please be careful that you don't stop when you solve something. Many of you have the habit, if you solve something, you think you're done. But what was the question? It said find the particular solution y equals f of x. So you actually have to rewrite y equals a, oh not a, sorry, 2 e to the 1/3 x cubed plus 1 to get your right answer. That would be your full amount of points. I'm pretty sure this part of the question right here is 6 points. Part B was 1 point, and part A was probably 2 points. Almost positive on that. Okay? Any questions on that? All right. Homework. I want you to circle these specific questions. So on the back, at the very back, I want you to do the last two, which are 32 and 33. One of them looks like the one we did today, but then the other one looks very different, purposely picking one that's very different. So the last two, 32 and 33. And then the multiple choice question. So all multiple choice questions, you'll do the evens. All multiple choice, the evens. They do stop at some point and they all start to turn into free response questions. They are always separated. You'll only do the evens of the multiple choice. If you're someone that knows that you need extra practice, you're someone that does horribly on tests, because the tests come directly from these kinds of questions, then do some extra. Okay? Because that should take you 10 to 20. That should take you somewhere around 40 minutes maybe to finish. If you have a little bit of extra time, try a few more multiple choice or try an extra free response. Pick one that you think looks hard. Don't do the easy ones. Okay? You want practice on the things that you're not good at. All right? Each day, check on me, make sure I turn on my headset, and then also make sure that I tell you which questions to do, because some of the packets are really long. What that means is that they're very important. When they're short, it means they're not as important. So the longer packets, you'll have a little more homework than others. This is a medium packet, medium to low, I would say.